things that are coming up, right? So you have your mastering due on Wednesday. We have an individual quiz today, group quiz on Friday. Your exam is a week from today, so we're going to review on this Friday. So again, if you have questions, you want me to go over practice tests are already online, you can go ahead and look at it and start working through some of those problems this week. We're almost out of lecture days, right? So we have our exam next Monday, then we have Wednesday, Friday for Chapter 19, then the next 2 weeks from today is our last day of class. And then you have your final. It's a standardized cumulative, yeah, just like 108. Means, yeah, so there's going to be a little bit of, on this standardized test, there's going to be a little bit of stuff that you just, there's no way you would know it. It's, yeah, just like last semester. Yeah. It was curved 30 points. So, because it's 70 questions total, and most people, I think the highest we got in here was like someone got 40 out of 70. Got my 1 week class. Yeah, so that person got an A. So I curved it to be 100. I mean, 40 out of 70 is like 50-ish%. So, and part of it is you're not good standardized test takers, and that's fine. And part of it is there's material on there that you haven't seen, nor would you know. So it's kind of a combination of those two things. So, same thing going into this test. 1, a standardized test, that's trickier, obviously. And 2, there's going to be a few questions on there about like point groups and organic chemistry nomenclature, which I can't expect you to know, because I have not taught you that. So I recognize that you can't do as well, unless you're inorganic, in which case you should totally get those questions. Yeah. And I believe starting next week, they're going to, if you did not buy one of those Gen Chem review books, I think they're going to go back on sale in the lab, what do you call it, stock room again. So if you didn't buy one of those practice exam booklets, they should be back on sale next week. Just get practice answering multiple choice questions. So it's more of a skill than anything else. Alright, so let's talk about oxidizing or reducing agents, and then, if you have your calculator, you will need it today. We're going to do some calculations involving cell potentials. Alright, but first let's do some definitions. So oxidizing agents are species that can, who knows what I was writing here? I meant, they just can electrons. That's what it is. They can just do it. They can gain electrons. Somebody needs to start proofreading my PowerPoints. Yeah, species that can gain electrons for reducing agents are species that supply electrons. Alright, so a strong oxidizing agent has a strong attraction for electrons. They really, really would like electrons. Let's see here. So what element do we know on the periodic table, imagining it in your head, is the element that really, 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 really likes electrons? Fluorine. So S2 is the strongest oxidizer. Fluorine is willing to take on the electrons and become negatively charged. It really, really, really wants those electrons. Alright, so then the reducing agent is the species that supplies the electrons. These are electrons that are willing to be positively charged. So strong reducing agents. Are those that are willing to be positively charged. They're able to handle losing an electron and still be okay with it. So those are things like lithium, right? Lithium loves being positively charged. Or potassium, any of those guys, right, that are happier losing their electron to have a full octet. So these are strong reducers. Okay. So let's put some of that in context with a practice looking problem. Let me find a good half reaction to look at. Alright, let's say I have copper 2 plus and iron making iron 2 plus and copper solid. What species is being oxidized, the copper or the iron? Alright, the copper is going from 2 plus to what? 0. Is that an increase or decrease in oxidation state? Decrease. So is that oxidized or reduced? Reduced. So Cu2 plus was reduced, and that means the iron solid was oxidized. But then the question is, I also want to apply these agent words. I want to know which one's the oxidizing agent, which one's the reducing agent. So, looking at copper plus 2 and iron solid, which was the species that gained electrons? Copper plus 2 went from plus 2 to 0. Does it need electrons to do that? Yes, right? It needs 2 electrons. So copper plus 2 is the oxidizing agent. It's the thing that forced iron to get oxidized. It was reduced and it forced the other guy to be oxidized. That's the agent of oxidation. Alright, so if I look at iron solid, it went from iron 0 to iron 2 plus. Did it gain or lose electrons by doing that? It lost it, right? Because it went from 0 to plus 2, so it must have lost how many electrons? 2. So it must be the reducing agent. So pretty much if you were oxidized, you are the reducing agent. Those are opposite words in that way. Because you forced the other guy to get reduced. Questions on that? Okay. In that case, let's calculate. Alright, so the determinant of a reaction is spontaneous. We're going to look at the sign of E0. Alright, so these are our options of signs of E0, right? Greater than 0, equal to 0, less than 0. Alright, positive, negative, 0. If I have an E0 that has a positive value, what is that telling me about the spontaneity of my reaction? It is spontaneous. If it's spontaneous, which direction am I going? I'm going towards product, towards reaction, or you can't tell? Okay, towards product. Alright, what if I'm at E0 equals 0? Where am I at? At equilibrium. Does that mean I have stopped making products? No. What does that mean? I'm making as many products as reactants, right? I'm right in the middle. I'm going a little forward, a little back. I'm balanced out. Alright, so then what does it mean if I have a negative E0? Non-spontaneous. So which direction should my reaction go? Towards reactant. Alright. If I'm talking about spontaneous and not spontaneous, what's the other letter that should pop into your head? G, right? So somehow we're related to G. If I'm towards products or towards reactants, what's that letter? These are G's. What tells me about products and reactants? K. So this must mean that E is related to G and E is related to K, because they tell me similar information. So let's look at how E and G are related first. Alright, so using my math derivation abilities, I just went ahead and did this for you. I'm assuming you guys weren't real passionate about figuring out how that is. Alright, it can be shown, which I would love to show you again someday, somebody will take me up on that, how to get from E to G0 equals negative NFE. So, let's look at what this is. Alright, so that's Gibbs free energy. What units should Gibbs free energy have? I'll take two options. Yeah, either kilojoules or joules. Either one, that's fine. That definitely should be an energy unit of some sort. Alright, then we have E0, right? That was our standard state voltage. What unit should voltage be in? Volt. Good. Just checking. Good. Everybody's breathing. Alright, what has N stood for every other time we've used it? Mole. What am I looking at moles of when I'm talking about voltages? What do you have to make sure is balanced in your two half reactions? Electrons. So this is going to be moles of electrons. So it's how many electrons are required to get everything all balanced out. Alright, so then the last one is our new guy, one of my favorites. This Faraday's constant. Alright, so it's 9.648 times 10 to the fourth. What sort of unit should I be in? Probably. If this is moles, and this is joules, oh, sorry, this is moles, this is volts, and that's joules. Joules per mole volt. Alright, so then let's look at how these two are related. We just said, right, E needs to be positive for spontaneous. If E is positive, is F positive or negative? Positive. What about moles? Can you ever have a negative mole? No. So this is a positive value, positive value, positive value. Why do I need the negative sign? Right, so if E is positive for spontaneous, what value does delta G have to be? Has to be negative, right? So you have to have this negative sign here to flip the sign, right? So E has to be positive for spontaneity, but delta G needs to be negative. So you have to have that. So in case you forget when you're writing things down, make sure you have that negative sign there to flip the sign. All right. In that case, questions about that first? Pretty exciting. All right, we'll do this equation, and then we'll do a bunch of practice problems. All right, so if G is related to E, G must also be related to K. All right, so redox equations, right? If they're at equilibrium, they must also relate to delta G. So we can combine that with the other equation we just had, right? So if delta G equals this and delta G equals this, right? I can say those two are equal to each other. Parts are good, right? This must be equal to that. But I want an equation that relates E and KEQ. So I need to have E on one side and everybody else on the other side equal sign. So how would I get the E by itself? So I have E0 equal RT and ln of K. And I write it in this way so I know I'm taking the natural log of just the K. Sometimes if you put it all on top of the fraction, that natural log starts to drift and you take the natural log of the wrong values. So I suggest doing it this way. Now, because the negatives canceled out. Alright, so let's look at these new-ish variables. What is R? Can I remember R? Right, it's the gas constant at 8.314 joules per mole Kelvin. Alright, T is obviously temperature. What units should my temperature be in? Kelvin, okay. Alright, and we just saw F was my Faraday's constant. Alright, then N again, moles of electrons. Alright, so let's look at this parentheses right here, RT over NF. What value will this parentheses have all the time? Positive, negative, or 0? Right, everything in here is always going to be positive, right? So that's a positive thing. So I could say, right, just for shorthand. Alright, so let's look at some different scenarios. If I have a K greater than 1, which direction is my reaction traveling? Towards products, towards reactants, hanging out in the middle. Going towards products. If I take a natural log of 2, if you don't remember what kind of value it is, you might want to plug it in, natural log of 2. What sort of value is that in here now? Well, I'll double check. Alright, ln of 2. There we go. Nope, positive. Okay. So if K is 2, natural log of 2 is positive, so what is E0? right? Which still makes sense. Spontaneous storage products. Again, they're telling you the same information. It's just a different equation using them. Okay, so now if I have a K less than 1, which direction is my reaction traveling? Towards reactants, right? So what sign should E0 have? Using this equation, could you have a K equal to 0? What does K equal to 0 imply? Chaos. Implies chaos of some sort. You have tragically made a mistake. Right? Because you try to take the natural log of 0. Natural log of 0. Yeah, domain error. Doesn't exist on our natural number line. So, K has to be a value greater or less than 1 to tell you about positive or negative E0. Alright, so now we're ready to try it out. The excitement in here is palpable, I can tell. I'm just pretty pumped. Alright, here we go. Alright, so I have an easy little get started reaction, no biggie, right? I have iron ions and some nitrates and some protons making nitrogen monoxide, water, and some iron ions. I would like to know the delta G in KEQ for this reaction, given that's at room temperature. Easy peasy, right? Let's first check our reaction. Is this equation mass balanced? Yes, right? Same number of irons on both sides, nitrogens, oxygens. Good, okay. Is it charge balanced? Yes. Do we have to do anything crazy to get started? No, I'm trying to help you out. This one's all balanced for starters. Right, we'll start easy. Alright, so good. Check the mass. Good. Check the charge. Good. Okay. In order to find, right, the delta G, if I want to find delta G, do I, by looking at this equation, know how many electrons were transferred? What do I have to do in order to figure out how many electrons were transferred? I have to do 2 half reactions. What would you guys like to do? The iron or the nitrogen? Iron, excellent choice. That's the one I would have chosen. Alright. I'm going from 3 iron plus 2s to 3 iron plus 3s. Have I been oxidized or reduced? Oxidized. How many electrons do I need then as a product? 1 each, so 3 total. Good start. Alright, so let's look at the other guy. Just for good practice, you really don't have to, because it's already balanced, but, you know, we're here. Not like you're going anywhere for the next 25 minutes. Alright, which element then was reduced in this case? Alright, so let's look at the H's. I have H plus over here. Actually start off easier. Oxygen is always what? -2. So I have 6 minus 2s, and overall it's -1. So what must be the nitrogen over here? Okay. If nitrogen's always -2, what's nitrogen over here? +2. In general, the oxygen and the hydrogens are never going to change oxidation states for the problems we're looking at. So it's going to be whatever other element is hanging out in there with them. Going from 5 to 2, that's definitely reduction. And to go from 5 to 2, how many electrons do I need? 3. Good. Alright, so now I know N. How would I go about figuring out what the overall cell potential is for this reaction? Right, we only have one equation for that. Right, cathode minus anode. Where would I find those E0 values? Either in the table, or I'll be helpful and I'll give them to you. Let's see. The iron, negative 0.77 volts. This is alright, so you look them up where they're given to you. Is the iron reaction at the anode or the cathode? The anode, right? How do I know? It's the oxidation. Oxidation is always at the anode. Good. Alright, so it must be 0.6 minus negative. What unit should I have? Volt. Good. Alright, now we are ready to solve for delta G. Alright, so negative. I did not leave myself enough space, so I apologize in advance. Yep. Let's see. Joule per mole volt. Oh gosh, this is crazy looking. I'm sorry, guys. Let me rewrite this. Try it again. And then 1.734. Alright, does that sign of delta G make sense with what you calculated E0 to be? Yes, right? We had a positive E0, which indicates spontaneous. We have a negative delta G, which also tells us spontaneous. Good. So then I want to find, right, that's part one, that's delta G. I also want to find KEQ. So you could find it this way, right? Or, since we just found delta G, you could also use that equation, right? Depending on what information is given, you could go back and use your E0 again and find K, or because we just found delta G, you could skip ahead to this equation, knowing you're going to rearrange a little bit. Either one's fine, doesn't really matter. Preferences? E's, G's? Do the G's. Okay. Alright, so let's see. How do I know what temperature I'm at? One, it told me, right? If you can't remember, one, it told you. The other one, what do these zeros mean? Standard state, what's temperature standard state? 298 Kelvin all the time, always. Alright, so let's see here. -5.2, fifth, Alright, now, how do I get rid of that natural loggy thing? Yeah, so it's e to the how are we doing looking at compared to 1? Are we above 1? Just a few zeros above 1. Would this be a product favored reaction? Yes. Yes. Okay, good. Questions on that one? Okay. How about we do another one of those? Because we're not ready for we'll wait on this one for not standard state. We'll do one more standard state one. Okay. Alright, so given that reaction, lead and magnesium make lead and magnesium. I want to find the K. Alright, what's the one thing in order to use this equation I have to, well, two things. Two things you have to know in order to find K. Temperature, moles, and what's the third thing? We're looking for K. E, right? So in order to find moles, what do I, well, you don't have to. How do I figure out how many moles of electrons have been transferred? We can do the half reactions, right? So I have Pb2 plus, next Pb solid, and I have M. In this case, you can certainly just look at it because it's not a tricky equation, right? I'm not trying to balance it in acid or base or anything wacky. It's just a how many electron transfer? 2, right? Because I have right, this one's a straight up 2 electron transfer, so you can kind of eyeball that, and that makes sense. The only reason you may want to write out 2 half reactions, is so that you can figure out which one was oxidized and which one's reduced, so you can get your E zeros off of the table. So it's the lead half reaction, the oxidation, or the reduction. Okay. Then this must be the oxidation. And you would look up on the table, or it's in the book someplace. Let's see here. Alright, so then how do I figure out the overall E0 cell? It's what minus what? Cathode minus anode, so is it the reduction or the oxidation that I put down first? Reduction, right? Double check my math. Is that E0 telling me that's spontaneous or non-spontaneous? Okay, so what should I expect my value of K to be? Positive. What side of 1 should it be on? Greater than 1, less than 1. Okay. Well, let's double check. Alright, so now I have 2.24 volts. Alright, nobody tells you anything about the temperature. What's a great assumption you can make? Standard state. Alright, how many moles of electrons were transferred? 2, right? 2 moles. Let's read these. 2 moles. Alright, so 8.3 4, 5, 2. Something like that. I'm just doing it off the top of my head. I didn't actually do this problem this morning. Everybody else get it? You guys are very trusting. Are we on the correct side of 1? Yes. Good. Is this product or reactant favored? Product favored. Alright, I will stop there so you guys have this time to do your quiz. We will finish up this chapter on Wednesday and review on Friday. Alright, so you will need